Hi, my name is Mike Griggs. This is a tutorial for 3D World magazine. I'm just going to take you through the basics of how I created this image in Xparticles, which is a fantastic plugin for Cinema 4D artists from Insidium. It is a full FX package that includes particles, simulations, warp sims, gas sims, dynamics, a whole kit and caboodle, and it is very well integrated within Cinema 4D. This is the scene which was used to create that render that we were just looking at, and in here I have 3 particle simulations, each one referencing a couple of very simple bits of geometry, and as you can see we can create complex things fairly quickly. So let me just take you through some of the basics of using Xparticles. I'm going to create a new scene, and let's create our basic shape. So which we're going to use as a starting point for our particle movement. So there we go. That's just a basic helix, and maybe I'll increase the end angle to 1440. No, actually better at 720. Okay, so that's the basics. We have a spline here, which we can tell Xparticles to follow along. Xparticles is accessed in the Xparticles menu. There are a couple of ways to initiate Xparticles. One is to add a XP system which keeps all your elements organized, but for what I want to do, let's just do it very simply and basically, and I can take you through the various iterations. So first of all, let's just have our balls moving down the spline. So to do that, let's create an emitter, and just going to rename that balls, and we are just going to change that to a sphere. Oh, not sphere, a circle. Reduce that down, and to get it to be right at the end of our spline, I'm going to go align to spline, helix, and just make that tangential. Just delete that because I don't need that anymore, and just pull that back. Okay, so if we just press play, you can see we now have an emitter emitting particles. So how do we get these particles to follow the spline? Well, there's a couple of ways to do. Well, the easiest way is to use modifier, and there's a range of modifiers for control, motion, generating elements called sprites, and various geometry elements. But what we need is a motion, and what we want it to do is XP follow spline. And so for this one, all we need to do is drag our helix into the spline, and we can use specific segments of the spline if we wanted it further up. But for what I need, it's fine at number 1, particle speed, that's all fine. Okay, so watch what happens now. There we go. Now, not sure if you can see on screen recording, but there's lots of green dots happening all around here. Now that's not exactly what we want. We want a bit, sort of the width of the circle around that. That's easy to fix. In our follow spline modifier, we just set our offset value to, say, maybe be 20. Oh, that's maybe too much, but as you can see, that's made a huge difference and is pretty much doing exactly what we want. Let's try 10. Yeah, that's great. Okay, now it's not going throughout the whole length of our simulation, so I'm just going to increase the simulation length to 500, drag that out, and move directions forwards, turbulence, no, drawing mode, speed parameters, there we go, and we want to complete the length in time. So in the complete length in time, let's just set that to 500. Okay, so now, there we go, slow down, and it's going to go down the entire length of our spline and the desired length that we require, which is great. Now, maybe we've got too many particles, that's absolutely fine. So if we go back to our emission, let's put that down to per frame, and maybe do, say, 15. That's better. Now, as you can see, if I just move that back, you see how the particles are speeding up here and then slowing down. That's because our particle speed here is 150, and it's being captured by the XP follow spline modifier and then working at the speed that we've set here. So you can already start to see that modifiers and various other elements within xparticles can control particle speed. It's not all a constant set speed. The other thing that we can potentially do is, if we wanted a bit of variation in that, we could add a go back to use particle speed so that it's being generated from the emitter, but we want to slow that down a bit. So go back here, slow it down to say 32, and there we go. We've got a nice slow animation, but I just want to add a little bit of variation. We'll put that up to the maximum allowed, and as you can see already, we're starting to get a much more natural looking set of particles. The other thing we can do is, if we can't see it particularly well, we can put this up to, say, spheres. That'll do. And it might be a bit small. Okay, spheres, that's great. Again, I think we might have too many particles, so I'm just going to drop that down to, say, 5 per frame. Yeah, that's great. Okay, so I'm happy with that. Let me just lower it down, just say to 2. Yeah, that's much better. Now, in our render, we've got various colored elements. So how do we do that? Well, there are a couple of ways to do that. One is that we could use another modifier called a color modifier, and we could set that to be a gradient. Let's just say blue and yellow. Okay, there we go. Okay, the reason that they are flickering is that we need to define exactly what we want to happen with them with the particles when they are launched. So let's move it to speed dependent. So if the upper speed boundary is, say, 64, because in our emission we have speed of 32 and variation of 32, that means there's a potential maximum speed of 64. Do 64. Oh, let's just add, show that yellow is actually yellow. There we go. You can see we've got a range of colors now, various speeds. The slower ones are blue, and then they turn yellow. So that gives you a quick idea of how to set the color with the XP color motion modifier. There is another way using xparticles question and answer system. So I'm just going to delete that. So in our emitter, there is a way to get xparticles to respond to question and answers, basically yes no statements. If a particle is doing this, it will then do that. So let's add a question. So particle data, we're going to change it to speed is greater than, say, let's do the 32. We're going to add an action, and we are going to change our spheres to, this time we're just going to do it red. Make sure we're not starting on red already for our, nope, green. Okay, so yeah, there we go. Other actions, editor display only. And there we go. So again, the velocity is being affected by our question and answer, which is affecting the color. And there we go. So a couple of easy ways to start to manipulate our particle system. And I hope you can see already with our 1, 2, 3, 4 elements, how quick and easy that was. I mean, you've got my waffling on, but yeah. And if we wanted to do more things such as vary the size of the particles, we can do that kind of thing. The other thing we can do is we could set modifiers to kill the particles when they get to the end of our spline. So XP, the easiest way is to XP follow spline, actions at end of spline. We can add an action. We can do a control modifier action. Kill modifier, and so there's a modifier called control kill. So kill modifier action, drag that in. Modifier will affect particle. If we can see, we've got a big box, so we'll just tell that groups affected within our kill inside bounds, and now hopefully, yeah, when this gets to the end, this should just start to kill the particles. There we go, perfect. Okay, so now that we have our first particle system set up, that's great, but I want to add another particle system that's going to move some geometry along the same spline, and in this case it's these rings. So I'm just going to go and get my ring. Just copy that. Okay, so that's just a bog standard piece of geometry, nothing special about it in any way whatsoever. So X particles can use multiple emitters in the one scene. You don't have to re-render and do various other elements. So, but the key to it is efficient uses of groups. So let's just create a group and call this one particle group 1 balls. And then what I'm going to do is groups affected for each of my modifiers and elements that have been created, just to make sure that everything that needs to be is tied to my particle group balls, so that it's not going to affect anything to do with my ring. And so to make that even more clear, I'm just going to dump all that under there. So that all should still work nicely. Okay, that's great. So next thing I'm going to do is going to make a new X particles emitter. Call that XP rings. And just do exactly the same as we had before, but this time I'm just going to add another group and change the color. Okay. So with the rings, again, we are just going to make sure our particle group balls is the only one being affected by that. And particle speeds. Yeah, well, that's good. Doesn't really matter the shape of this. I'm just going to copy the coordinates of copy to the rings. It's identical. There we go. So we can now export modifiers, control, motion, sorry, and follow spline, drag that in, particle group effect, particle group 2, and just drag in our spline. But the thing that we need to do is just add these rings, because at the moment all we are doing is, as you can see, some little red dots. In fact, if I just hide these, yeah, you can see we've got the same problem as we had before. So what do we do to add this to our particle system? We go to X particles, XP generator, drag that in here, again, groups affected, particle group 2, and we make our tube a child of our generator. So we've got to be careful now, because with this amount of geometry we could get ourselves into a pickle really quickly. So what I'm going to do is I'm going to reduce my birth rate to 3 per second. I'm going to change it to my emission mode to pulse, and every 30 frames we're going to pulse 3. What I forgot to do was add my emitter rings into my XP generator. So now, okay. Okay, so as you can see, there are quite a few ways that that's wrong. Primarily, we're having an issue that my rings are not following the direction of the helix. I want it to be a tangential direction. That's easy to fix. If you go to our XP emitter rings and go to our extended data, click on use rotation and just set that to tangential. And there we go, captured and moving down. Okay, so in our emitter rings, we are just going to make sure our speed is the same as before. Our birth rate is 3, and let's just see what happens. Okay, I've reduced our birth rate down to 3 so that we don't get millions of rings, because that would just slow your system down. So that's all fine, but it's all a bit just random. So I want a bit more of a pulse, so that's dead easy to do. If we just switch our emit rate to emit all frames to pulse, and I've got this set to length 3 frames, interval every 30 frames. So if we take that back to the beginning, just play that, you can see we've got much more of an ordered pulse. And I've just set my birth rate to 3. That's absolutely fine. If I was to drop that back to 1, let's see what happens. Yep, that's better. I think we had a few too many rings there. And if I was to drop my length down to 1, just get 1 pulse. So again, let's do that, and then let's increase our speed variation so we get more random. Okay. The other thing we can maybe look at doing is seeing if the radius of our particles. Nope, that doesn't make sense. So why is that not impacting on our geometry? That is because in our XP generator, if you do scale, let's just set the scale within, if we do 0.5, 0.5, 0.5, and then 0.25, 0.25, and 0.25. Yeah, there we go. Got some variation. Okay, so now that we've got those chaps working, let's move on to our final element, which is the tendrils around. Now we're going to use a slightly different system for this, in that we are going to create a bit of geometry. In this case, I'm going to use a capsule. I'm going to reduce the size of that, and I'm going to use a spline wrap. And tie that to our spline. Oh, just get that in the right orientation. There we go. And just add more height segments to make it nice and smooth. Yeah, I'll do. And just a few more cap segments. Okay, so now I'm going to create a final emitter. In fact, what I'm going to do with this emitter is just copy my first one and duplicate that. I'm going to make a new particles group, group, and call this trails. Drop that in there. Switch this meta group to be trails. Set the color of that to be yellow. And just make sure questions are removed, that's fine. So the other thing, let's just add a display tag so that we can just lines, isoparms, okay. So now that we can see but not see our capsule objects, that's great. Just going to switch off these guys for a second. Okay. So okay, there we go. XP emitter balls is happening. There we go. Let's just change that to circles. There we go. So the particle group is controlling the size of our display particles. That's fine. So what I don't want to happen is I do not want that many particles to be that many trails. So again, going to emission mode, we're going to just do a shot, a single shot, and bang. That is a lot of particles. So let's reduce our shot count down to, say, 32 seems to be winning for us. Okay. Right, so instead of following the spline like we did before, what I actually wanted the particles to do is go around the surface. So for that, I'm going to use a modifier motion XP follow surface. Drag that in, groups affected, X particle trails. Okay, and let's drag in our capsule object. Let's just watch what happens. There we go, spinning round. Then it spins back at the end. We can add a bit of friction to that. Let's add quite a lot of friction to that. Yeah, and that stops everything. So let's. This friction is capturing the speed and basically decelerating that. We got that slowed down quite nicely, and it's just working its way through. The friction is slowing things down quite considerably. What I want, though, is obviously for these to be trails. So let's add an XP trail object, drag that in, and groups affected, particle groups, XP trail. The reason that's not working is because I haven't added my emitter, groups affected. There we go, objects. Alright, so there's a range of things that we can do with the trails object. So if I just switch that on, you can see we're drawing some splines. That's lovely. And there's some really cool things that we can do with these. So it doesn't necessarily just have to be moving splines like that. I'm just going to slow down the emission rate just a touch. There we go. Follow surface. Let's just add our friction up a little bit. Okay. So if I just highlight that. Some other things that we can do with this, we can change the algorithm to be, we can create algorithms to connect all the points. So if we just did a nearest by distance, we'll just use only same group. I'll just switch our particle back to, instead of dots, just dots. You can see we're getting just some little elements there. If I was to change that from shot to rate, and just, you can see we can get a sort of linear little element like a skin, which can be really useful. There are other ways that we can do nearest by distance. We can do clusters, which are quite interesting. Extreme with the amount of geometry they produce, so that takes quite a lot of management. There you go. So you can start to get some plexusy type effects, and there's a range of tendrils are another good one. But for that you need a tendril modifier, and that's a good way of generating extra geometry off the main particles that you're creating. But for this I'm just going to go no connections because I quite like what we got. But what I want is slightly more constrained movement, so for that I am literally going to use an XP constraint. Now these can have all sorts of effects on particles. One of the things that I haven't mentioned yet is that when you're adding all these various elements, if we go to the XP constraints, and so there we go. For any element that you add in X particles, there's these two little icons down here. This takes you straight to instructions dealing with that specific modifier or element that you have added. But what I find even more useful is if you connect to the internet, you get a video. And I can't stress how good all these videos are, and how I would love to see other plugin manufacturers develop a video and tutorial system like this, because we're all used in Cinema 4D to being able to go to show help and getting the requisite amount of detail about our object. But normally on plugins, what happens there is you don't get anything. But Insidium have really gone above and beyond with the amount of training that X Particles comes with, and to have it just within a moment's notice of a click is great. Okay, so just going to add a bit of viscosity to our trail. Comes affected, and as you can see, that's really changed the dynamic properties of the particles as they move around, giving a much more flocking. I mean, there is a XP modifier for flocking, but I really like this. It gives that much more bundled appearance. We can also add, and let's play with this to our heart's content, and maybe try a little bit of surface tension, see what that does. Again, it's all experimental. No, not a big fan of that, but yeah, learning how to use constraints can impact hugely on how you use X particles, because they can add dynamic properties such as colliders, etc., to your particles, which can be really useful. And in many ways, an X particles dynamic system is quicker to set up than a traditional Cinema 4D dynamic system for certain tasks. But for what we want, I'm happy with that. Now, the only thing that we haven't done is if I switch all these guys back on, there we go, we've got all our various elements rendering. Now, if I just hit render, if I hide my capsule and just hit render, what we're not seeing is the particles, and that is because we need to add an X particles material to our emitter. There we go. So, but we're definitely not seeing our trails, so what we need to do with that is in our X particles we add an XP spline mesher, add that to this, and add our XP trail object as the object. And as you can see, we need to reduce our radius, say to 0.2, and again, lots of different things that you can do within this. And there we go, we've got the beginnings of a really nice system that we can take into your renderer of choice and go crazy with. Okay, so we're just cut back to my main scene that I created earlier, our starting scene, and just there's a couple of things that I just want to go over from a point of view of making things much more efficient. One of the things that we can do if your machine's starting to slow down is use the XP cache, which will cache your XParticles data wherever you want it. Just going to do it to my big drive here, bang, and just hit build cache. Okay, so now that we have cached, we have the ability to scroll and scrub back through our animation, which is hugely powerful. Okay, just going to show you another thing that can be done within XParticles, which is to create fluid simulations. So I have just created a domain, and within this domain, it doesn't have to be fluid, it could be gaseous, fires, whatever you require, but let's do a liquid. I'm just going to create a XParticle emitter and make that a sphere, drag that up there, and oh, why is that not falling down? The reason that that is not falling down is that I have not added some gravity, so that should help. There we go, and as you can see, just got the beginnings of a nice fluid sim. The good thing about the domain is that we can start to do all sorts of things. So if I didn't want a wall on my plus X, pour out, and there you go, we've got some pouring elements. And again, as we've looked at, you can adjust color, speed, all that kind of thing. But one of the nice things, in fact really useful things within this, is that we can create dynamic elements. So I'm just going to create the sphere. This methodology works for creating anything dynamic within XParticles, not just fluid systems. I'm going to make an XP collider on the sphere. There you go. We have that pouring out. I'm just going to reattach my wall. And again, we could potentially use a constraint, so I'm going to add a bit more viscosity. Yeah, it's starting to look quite interesting. Let's reduce the stiffness a bit. The other thing I'm going to do is I'm going to increase particle count and reduce that to say 50. But let's see how. Yeah, that's great. And the other good thing about this is that this should be, yeah, it's interactive, so we could animate splashes. So I'm just going to quickly cache this. Other objects, cache, build cache. Just show you the other thing that we can do with fluid simulations. So that is just pouring off that. That's absolutely fine for what we're doing. If we add a XP skinner and we add our emitter, you can quickly see that we have the beginnings of some fluid. Now, it's going to take some guessing as to which sort of element's going to suit you best. One, reduce your polygon size. Just remember that whatever polygon size that you do here, once you get it to a size that you're happy with, that you match your render polygon size as well. Now, I know that looks fairly not great, but if we add a smoothing to the skinner, there you go. Start to see that that is the beginnings of potentially something quite useful. And again, just having this within a paradigm that you are already used to for your FX tools, so that the fact that you have your water simulations and your gas simulations take the same methodology as your particle simulations means that you are not consistently trying to have to relearn how to use the wheel every single time that you want to create something complex like an FX system within Cinema 4D. So I hope you can see this is yet another tool that Xparticles adds to the Cinema 4D toolset. And my name's Mike Griggs. I hope you've enjoyed this series of small tutorials about Xparticles, and I will speak to you again soon. Okay, just going to show you another thing that can be done within Xparticles, which is to create fluid simulations. So I have just created a domain, and within this domain, it doesn't have to be fluid, it could be gaseous, fires, whatever you require, but let's do a liquid. I'm just going to create a Xparticle emitter and make that a sphere, drag that up there, and oh, why is that not falling down? The reason that that is not falling down is that I have not added some gravity, so that should help. There we go. And as you can see, just got the beginnings of a nice fluid sim. The good thing about the domain is that we can start to do all sorts of things. So if I didn't want a wall on my plus X pour out, and there you go, we've got some pouring elements. And again, as we've looked at, you can adjust color, speed, all that kind of thing. But one of the nice things, in fact really useful things within this, is that we can create dynamic elements. So I'm just going to create the sphere. And this methodology works for creating anything dynamic within Xparticles, not just fluid systems. I'm going to make an XP collider on the sphere. There you go. We have that pouring out. I'm just going to reattach my wall. And again, we could potentially use a constraint, so I'm going to add a bit more viscosity. Yeah, starting to look quite interesting. Let's reduce the stiffness a bit. The other thing I'm going to do is I'm going to increase particle count and reduce that to say 50. But let's see how. Yeah, that's great. And the other good thing about this is that this should be, yeah, it's interactive. So we could animate splashes. So I'm just going to quickly cache this. Other objects, cache, build cache. Just show you the other thing that we can do with fluid simulations. So that is just pouring off that. That's absolutely fine for what we're doing. If we add a XP skinner and we add our emitter, oh, and we add our emitter, you can quickly see that we have the beginnings of some fluid. Now, it's going to take some guessing as to which sort of element is going to suit you best. One, reduce your polygon size. Just remember that whatever polygon size that you do here, once you get it to a size that you're happy with, that you match your render polygon size as well. Now, I know that looks fairly not great, but if we add a smooth Smoothing to the skinner. Okay. Start to see that that is the beginnings of potentially something quite useful. And again, just having this within a paradigm that you are already used to for your FX tools, so that the fact that you have your water simulations and your gas simulations take the same methodology as your particle simulations means that you are not consistently trying to have to relearn how to use the wheel every single time that you want to create something complex like an FX system within Cinema 4D. So I hope you can see this is yet another tool that Xparticles adds to the Cinema 4D toolset. And my name's Mike Griggs. I hope you've enjoyed this series of small tutorials about Xparticles, and I will speak to you again soon.